Good morning, dear students, and welcome to Vista's Learning, an online educational platform. My name is Denzil, your physics tutor for class 11. So for today's session, we begin with a new chapter. And this chapter is quite fascinating one, is because it describes our universe as well. So this chapter is about motion in a straight line. This would be a session 1, just an introduction to the chapter of motion in a straight line. So let's dive into the session and have a look at what is our objective. When it comes to understanding motion of an object, the study is done under 3 different categories, and those are kinematics, one, which is kinematics. Kinematics is the study of motion of the object without any regard to its causes. What does it mean? Study the motion of an object. So let me write that. Study the motion of object, but no without any regards to its causes. So what is this causes? Causes meaning what causes the object to first of all move. So we are not bothered about it, especially when we deal with the subject kinematics. So it is just the study of motion of an object. On the other hand, there is also dynamics. Dynamics is a study of motion of an object with regards to its causes. So this is a study of motion with causes. So what causes the object to move? That detailed study is done under dynamics. So you might have learnt about in the lower sections as thermodynamics as one of the chapter, or you might have come across electrodynamics as a chapter as well. So where dynamics itself means study of motion of an object with the causes. And third is statics. Statics is a study of object at rest. So you make a study of an object, especially for those which are at rest. Study of object at rest. Couple of examples of this statics you might have learned in the lower sections as electrostatics. Electro meaning charges, statics meaning rest. Charges, study of charges that are rest, electrostatics. Magnetostatics, and few other study which they deal with the object which are at rest, they are termed under statics. So how do we truly define these two physical states called rest and motion? So how do we define these two? When we compare each other, to give few examples, it is very easy. If I ask you, give few example of object in motion, you would definitely give. Some of them are flight of a bird, the rising and the setting of the sun, or a grandpa that is walking across the street. Though the motion is slow, but is still moving. So if those are few examples of objects which are in motion, what about examples of those objects which are at rest? A stationary book, or a stationary table, or you being stationary at the moment watching this video. So you know how to give the example of objects that are in motion and objects that are at rest. But how do you truly define one quantity with the other? How do you distinguish them as well? So how do we truly define an object which is in a state of motion, and for those object which is at a state of rest? So how do we distinguish these two quantities? Now have a look at this. Now, I am stationary, meaning I am not moving at the moment. I am located at this position. Now, if I have to get to the other position which is located there, all I have to do is take a couple of steps forward. Easy task. So, from there to here, I moved, therefore I was in motion. Now for that motion, what you also observe is that I changed my position from one place to another. While I change my position, okay, let's do it one more time. I take steps forward, I am changing my position, and that is why I am in motion. So how do we define objects that are in motion? When an object changes position. When an object changes its position, then we say that the object is in motion. Now can you define how an object is at rest? If an object is changing its position, then it is moving, which means it is in motion. What about rest? Will the object move? No. For objects which are at rest, they do not change position. When object does not change its position, if an object does not change its position, then we say that the object is at rest. Couple of examples. Flight of a bird. One example for object which is at rest. A stationary book. I'll just write book at rest. See? Okay. So now you go ahead and write more examples under objects that are in motion and for those objects which are at rest. Now there's a little problem here. I'll tell you what the problem is. Let's say you're traveling in a bus and you're sitting near the window seat. Now, when you're traveling in the bus and you're sitting near the window seat, are you moving? Well, for you who are sitting in the bus, you're not moving, but the bus is moving. So the outsider will see that you are moving, whereas you who are sitting in the bus is at rest. So let's have a quick look at this. A bus that is moving and you're somewhere here sitting in the bus. Well, jolly good, you're dancing and having fun in a school bus, but now you don't get to travel in the school bus because COVID, right? So here we see that the observer, you're observing the bus moving, so the observer is you. You are being the observer. Whereas your friend in the bus who is moving is at rest. Therefore, the object what you look at is your friend. In such cases, you eliminate the confusion. In such cases, you eliminate the confusion who is truly at rest and who is truly moving. Because your friend might argue with you saying that he was at rest and you were moving outside. But you will deny that and say, no, I saw you moving in the bus whereas I was at rest. So to eliminate the confusion, we introduce who is the observer and what is the object. So in this case, you are the observer and the object that you're looking at is your friend. It could be the same case when your friend is an observer, and have a look at this. So now in this case, your friend is the observer and the objects that are moving outside are in motion. So the observer here is your friend and the objects, as you see, are moving. Well, that is only the state depending on the observer. Well, if the observer finds himself at rest, then he will find the other objects to be moving. So this, what we come to a discussion, what is called as a frame of reference. Frame of reference depends on where you are located. We will soon get to that in identifying how to locate ourselves within a given region of space. But first, a frame of reference deals with where you're located and what time does it take if you're moving or if you're at rest. If you're at rest, then over a period of time, your position will remain the same. But if you're moving, then what happens over a period of time, your position also keeps changing. So this frame of reference is applicable to an observer, okay, to make sure who is the observer and what the observer is looking at, meaning the object. Okay, so two different cases. Here we saw the observer in your friend, and here we saw the observer, that is you. Okay, so a frame of reference which relies on the position and time. So in a given frame of reference, meaning in a space that you're located and for a given time, the laws of physics must be applicable in that frame of reference or any other frame of reference that you're taking. The laws of physics must be applicable in such cases. So now, how do we truly define position? How do we locate ourselves in a given region of space? Now, you might have learned how to locate a point on a sheet. An example is a graph paper. When you take a graph paper, you locate where the point is depending on two reference axes called the x-axis and the y-axis. Now, if you have to stretch it to a reality, you need a third reference axis, which is called the z-axis. Now let us stick to the basic understanding, because our chapter anyways involves in motion in a straight line. Straight line, the other word for it is a rectilinear motion. Instead of using the lengthy terminology which is motion in a straight line, you could simply use the word rectilinear motion, which also means motion in a straight line. Now, for a motion in a straight line requires only one number line or one reference axis. Number line, you would have learned that in lower standards. What is the number line? First of all, what is a line? What is a line? This here is a representation of a line. So how do we put that in a words? Well, remember, it's nothing but a set of rays, two rays, which are extended opposite to each other. Remember what a ray is? A ray is a line that starts from a source and extends towards infinity. You have two sets of rays, one which is extended towards your right hand side, the other which is extended towards the left hand side. The point where they extend outwards, which are opposite to each other, is called the origin or the zero line or the zero location or 0 point. Now, towards the right hand side, you represent with set of positive integers. What are those positive integers? 1, 2, 3, 4, and so on and so forth. Now, representation towards the left hand side would be all negative integers, which are -1, -2, -3, -4, and so on and so forth. Now let's take an example of an object say a person who is located at a point 0. Now, if I ask you the question, what is the position of this person? Where is he located on a number line? On the point 0. So what is the position? What is the person's position? In this case, it is 0. He is located at point 0. Now, this person who's located at point 0 is at rest at the moment. Now, if I ask this person, all right, person, take 3 steps forward. Now, when he has to take 3 steps forward, he has to move, which means he has to set himself into motion. So he goes 1, 2, 3. He takes 3 steps forward. Now that he's taken 3 steps forward, what is his new position? What will be his new position? 3. Because you see that the new position here is 3. So let's make note of that. New position. Old position 0, new position 3. How much has this person traveled? To find how much this person has traveled, we use 2 different physical quantities. These 2 different physical quantities are called distance and displacement. To find how much the person has traveled, we use the term distance and displacement. All right. So now first let us understand what is distance, and then we will learn what is displacement. So what is distance? Distance is the total path traversed by an object. Total path length, okay? Total path length traversed by an object. Total path length meaning how much the person has covered by walking or by the object which has covered, total path covered. An example is, let's say you start from home and you need to reach to your destination, which is school. Now you may use a different various types of transport. There are school buses available, or you would take a bicycle to school, or you would go by any automobiles, or you even go by walk. Now, when you have to move from home to school, it is not just a straight path. Well, if you just have a straight path, meaning school and home being opposite to each other, then you're the luckiest student. Normally, we don't really have a straight path to the school. You have to go through turns and twists and turns and twists and turns and eventually reach your school. So this path that you take through twists and turns, the total length of those twists and turns are what is truly called as a distance. So it's like moving that, and you finally reach your school. So this, all the length that you go through this twists and turns and finally reach school is what is termed as a distance. So total path length traversed by an object. The SI unit of distance is meter, given by the small letter m. Yes, You might recognize this from the previous session where we discussed units and measurement, and there we noted down a dimensional analysis for a meter, which is the unit of length. So distance, SI unit, is a meter. So in distance, you try to measure the length. Okay. Now, how different is distance from a displacement? Let's have a look. Oh, one sec. All right. Okay, so I should draw it here. Displacement. So now that we have understood distance, now let's look into displacement. Displacement is defined as shortest distance between two points. And what are these 2 points? The initial point and final point. Okay, let's have a look at the same example. School and home. So here is home and here is school. Distance, twists and turns, and finally you reach the school. But displacement says otherwise. It could be the shortest, or it is the shortest distance between the two points or two positions. Which are they? Home and school. Initial position is home, or initial point is home, and final point or final position is school. Shortest distance are usually defined by a straight line. A straight line represents the shortest distance. So a straight line which is extended from home to school. The length of this straight line is what are usually termed as a displacement. You see how different they are, distance and displacement. What about its SI unit? Is it the same? Yes. Distance, yeah. Distance and displacement have the same SI unit, which is meter given by small letter m. And there is one more distinct feature about displacement, how you can distinguish from a distance. In case of a displacement, it usually relies on direction as well. It depends on the initial and the final point. Remember that. It depends on the initial and the final point, meaning it depends on a direction. Now, in this case, the direction is moving from home to school. So when you make note of this physical quantity, you write a number, let's say displacement is 5 meters, and you also make note of the direction. You will soon see that there are physical quantity which has this, some value with a direction, some physical quantity that have value but no direction. Couple of examples are mass. Now, when you say mass of an object is 5 kg, you don't ask in which direction it is 5 kg. It is a property of a matter that it has a 5 kg of mass. But whereas in case of a force, you say I apply a force. Now there it depends in which direction you are applying the force. Even in the definition which you have learnt in lower standard about the force, force is a push or pull, meaning there's a direction to it. A push being the forward direction, pull being the reverse direction or backward direction. So that is one extra distinct feature about displacement. So we will have a look at that in a later stage. about this feature where a given quantity has both a value and a direction, and some of the quantity that has only value but no direction. So we will discuss that in the next session. But kindly make note of this, the difference between distance and displacement. And now let us look at a quick example, an example for distance and displacement. Okay, example. You ready? Okay, let's get started. So a boy starts from his home and heads to a school. That's the same example as the earlier. Yeah, it's the same example from the previous case, but here we're going to assign some numbers. We'll give them some numbers. Okay, so he starts from home and he heads to school. Okay, so the path from home to school is a twist and turns. So I will represent it by this, where he moves straight, goes up, moves sideways, goes down, moves sideways, and then reaches school. Okay? Right. So now the distance from this point, let's say A, B, C, D, E, F, and G. Okay, the distance from A to B is 1. Okay, and then the distance from B to C is 4. Distance from C to D is 1. Distance from D to E is 4, distance from E to F is 1, and distance from F to G is 4. What is the unit? Meters. Meters, 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 meters. Okay? What is the total distance from home to school? Now remember, distance only relies on total path, but it does not depend on the direction. So don't take into consideration which is the direction. So what is the total distance? So if he moves from A to B, 1, 1 plus 4, 5, 5 plus 1, 6, 6 plus 4, 10, 10 plus 1, 11, 11 plus 4, 15. So what is the total distance traveled? 15 meter. Good. Yes. 15 meters. Easy calculation. Now comes the actual question, which is the total displacement. What will be the total displacement? Remember, based on the definition of displacement, shortest distance between 2 points, the initial point and the final point. Let us identify those initial point and the final point. Initial point here is A. Final point is G. Shortest distance meaning a straight line connecting the two initial point and the final point. So construct a straight line. Go ahead, construct it with me. A straight line. There you go. See? So this orange line represents the straight line. Now comes the measuring part. How do we measure this length from A to G? You may say it's impossible. Come on, shouldn't, it's not possible to measure. Unless even if I give a scale, I don't have that accuracy of 1 meter. This is actually not 1 meter. Realistically, this is just a rough sketch of showing you that it may be 1 meter, but it's not truly 1 meter. So how would you identify the length A to G? Well, a simple task which you would have learnt in lower standard as well. Now, recognize this CD, which is length 1 meter. CD and BE length will be the same, isn't it? Because if you close it by a figure, you get a rectangle. So the opposite side lengths must be equal. So CD and BE length will be the same, which is 1 meter. Okay, so how does it change? Now, what you obtain here is a right angle triangle. You see that? Yeah, you have a triangle. See, you have a triangle that is formed. Now, do you know the length of AF? Certainly you do. It is 1 plus 1 plus 1. 1 plus 1 plus 1, 3. So AF length is 3 meters. GF length is 4 meters. Now can you identify what is AG? Still not? Think about it. Two sides of a right angle triangle is known. One side is unknown. How will you identify this hypotenuse? By using Pythagoras theorem. So let's make note of that. Pythagoras theorem, which states that in this case AG square, which is equals to AF square plus GF square. So AG square, which is the shortest distance between the two, AF square is 3 square plus GF square is 4 square. So AG square, which is equals to 9 plus 16. So AG square equals to 25. AG equals to square root of 25. AG equals to 5 meter. Okay. And that is how you identify the shortest distance between the 2 points. So I hope I've made this easy for you, how to identify a given length, which is by distance as well as for displacement. We will soon see more examples that are based on these two physical quantity of distance and displacement, and we shall differentiate between one another and also discuss about this particular subject of physical quantity that has a certain value and also particular acts in a particular direction, physical quantities that have only value but has no direction. We shall soon see that in the next session. And do visit us at www.we-learning.in to get more details about the classes. And I shall see you all in the next session. So until then, everyone, take care and have a nice day. Bye-bye.